Hi everybody, once again I am here continuing with electricity, class 10 physics, and we are continuing with NCERT exercise. In the previous class we have done up to question number 40. So I am with question number 15 here. Question number 15 is two lamps, one rated 100 watt at 220 volt and the other 60 watt at 220 volt are connected in parallel to electric main supply. What current is drawn from the line if the supply voltage is 220 volt? Two lamps, one rated 100 watt, another rated 60 watt, both are connected in parallel to a supply line of 220 volt. What is the total current drawn by these two bulbs? So, two bulbs of this time, resistance are not given but powers are given, is connected to a supply line of 220 volt. 220 volt supply line, one is of power 100 watt and the other is of 60 watt are connected in parallel. We know that when two resistors are connected in parallel, what will split? I will split. Let us take, this is I1 and this is I2. The current used by the first bulb be I1, second bulb can be taken as I2. Now what is total I? I is equal to I1 plus I2. Now what is the formula for I? Remember this time V and P are given. This is not R but P. So what is the formula for I in terms of P and V? Always remember the formula. P is equal to VI. Therefore I is equal to P upon V. So let us calculate. Let P1 is equal to 100 watt. Given V is equal to 220 volt. Therefore, I, let us call it as I1 and let us call it as I2. Therefore, electric current consumed by 100 watt bulb, which is I1 is equal to, remember P is equal to VI. Therefore, I is equal to P upon V, or P1 upon V is equal to 100 upon 220 ampere. Now let P2 is equal to 60 watt. Here also V is equal to 220 volt. Therefore I2 is equal to P2 upon V is equal to 60 upon 220 ampere. Now we know that in parallel I is equal to I1 plus I2 is equal to 100 upon 220 plus 60 upon 220 ampere. 220 LCM, 100 plus 60, 160 upon 220 ampere. This is equal to 0.727. So the answer is 0.727 ampere. This was comparatively an easier question. In parallel, I splits from here. We have taken it as I1. This is taken it as I2. Now I is equal to P1 upon V. I2 equal to P2 upon V. Now I is equal to I1 plus I2. So this is the answer, 0.727 ampere. We see once again. Got it? Okay. Now question number 16. Question number 16 is, which uses more energy used? a 250 watt TV set in 1 hour or a 1200 watt toaster in 10 minutes. We have to find and compare the energy consumed by two things. One is 250 watt TV set. So power of TV set. Let us take it as P1 is equal to 250 watt. And it is working for 1 hour. Time T1 is equal to 1 hour. What is the formula for energy? Energy consumed E is equal to P into T. So let us take it as E1 and P1. Energy consumed by TV set is equal to P1 into T is equal to 250 into 1 watt hour is equal to 250 watt hour. Now you are given the power of, what is the second one? Toaster. Power of toaster, let it be P2 is equal to 1200 watt. 1200 watt. This is working for a time of 10 minutes. We know that. Since here it was given in hour, in the second case also it must be in hour. 10 minutes is equal to 10 upon 60 hours. Therefore, energy consumed by toaster, we can call it as E2 is equal to P2 into T is equal to 1200 into 10 upon 60 watt hour. 2. This is 200. 60, 1200, 2 into 10, 200 watt hour. See, here we have 250 watt hour and here we got 200 watt hour. So which one consumes more energy? Therefore, final answer, TV set consumes more energy. TV set consumes more energy. Simple formula, E is equal to P into T. So E1 is equal to P1 into T, 250 watt hour, E2 is 200 watt hour. So E1 is greater than E2. I hope you got it. Okay. So the next question is question number 17. An electric heater of resistance 8 ohm. Electric heater of resistance 8 ohm. So this is question number 17. R is equal to 8 ohm. Draws 15 ampere from the service main. 15 ampere. We know that ampere is the unit of I. So I is equal to 15 ampere. 15 ampere for 2 hours. Calculate the rate at which heat is developed in the heater. Calculate the rate at which heat is developed in the heater. What do you mean by rate at which heat is developed? Heat is a form of energy. So, it is same as saying rate at which energy is developed. Do you remember what is it called exactly? Rate at which energy is developed or consumed is called power. So here it is nothing but rate at which heat is developed. Rate at which heat is developed means power. Got it? Rate at which any energy is developed or consumed is called its power. Heat is also a form of energy. So in this question, you are indirectly asked what is the power consumption. Now what are given? I and R are given. And what is asked? Power. So what is the formula connecting P, I and R? And we know the formula. P is equal to I square R. P is equal to VI. V is equal to IR. So IR into I is equal to I square R. So in this question, the time is given for 2 hours. Since it is rate at which heat is developed, time will be get cancelled. What do you mean by rate? Per unit time. So time is immaterial in this question, whether it is for 2 hours or 3 hours, per time. So per time means even if we take time, finally then T and T will get cancelled. So rate at which heat developed means power. So P is equal to I square R. I square means 15 square into 8. 15 square 225. 225 into 8 is equal to 1800. What is the unit of power? Watt. Now what is the meaning of watt actually? It is joule per second. Since we are asked the question in this way, rate at which heat is developed. So we must say the final answer. Therefore, the rate at which heat developed is equal to 1800 joule per second. Therefore, rate at which heat is developed is equal to 1800 joule per second. In every second, 1800 joule of heat is developed. So an important point to be noticed in this question is to understand the meaning of the question as rate at which heat is developed means power. And the formula for power is I square R. Okay? So that is the answer. So with that, numericals are over. Now the very last question of this exercise and this chapter is question number 18. These are some word problems. Means not numerical. Explain the following. First one, why is tungsten used almost exclusively for filament of electric lamps? We know that the filament of almost all the electric lamp is tungsten. We have already discussed this in the chapter, because in every heating devices, the filament or heating heating filament is having a special property or common property, and the property is it will have high resistance value. Second, its melting point will be high. So in all such questions, you have to remember these 2 points always in your mind. In all the heating devices, the heating filament used, mostly it may be an alloy. Whatever it is, the reason is only two. Number one, it has high resistance value, so it will convert most of the electricity into heat, because we are expecting more heat. Second, they have high melting point, so they can withstand even at very high temperature, because heating devices produces lot of heat, so it must have high melting point, it must have high resistance. So same reason, tungsten is used exclusively for filament of electric lamps, because tungsten has high resistivity and high resistance. The one having high resistivity will have high resistance also. So it can convert most of the electricity passing through it into heat. Number two, it has high melting point, so it will not melt away even at high temperature. Clear? Question number 2. Why are the conductors of electric heating devices such as bread toaster, electric irons made of an alloy rather than a pure metal? Answer is almost the same, only that language is to be changed. This time you have to write this conductors of this made of an alloy rather than a pure metal, because alloys have higher resistance value than pure metal. Alloys have high melting point than pure metals. Reason is point is same, but you have to write the answer in comparison with alloy and pure metal. So alloys have high resistance value, so they can convert more electricity into heat. They have high melting point, so they can withstand even at high temperature. Both are connecting questions. C. Why is the series arrangement not used for domestic circuit? Once again, this question was answered in our in-text question. In series, what happens? V splits across each resistor when they are connected in series. But each appliance requires exact 220 volt for its efficient working. So if devices are connected in series, as the number of devices are getting more and more, V will go on decreasing. The same 220 volt will go on decreasing across each device. So each devices will not get 220 volt, which is actually required for its efficient working. So devices are never connected in series, but they are always connected in parallel. Because in parallel, V remains same for all the devices. Every device will get same V. The number 2 reason I told you, in series, if any one device got damaged, no other device will work because they are all connected in the same circuit. So if one device got damaged, the circuit is broken, no other device in that circuit can be operated then. So remember these 2 points. Next question. How does the resistance of a wire vary with its area of cross section? Again discuss. Resistance and area of cross section are inversely proportional. So when area of cross section increases, resistance decreases. Or we can say when thickness of a wire increases, resistance decreases. So simple answer, the resistance of a wire is inversely proportional to area of cross section. You can explain it in one more line. That is, when the area of cross section increases, resistance decreases. Last question. Why are copper and aluminium wires usually employed for electricity transmission? We know that copper and aluminium are the 2 metals mostly used for electricity transmission. Aluminium wires are used as overhead wires. Copper wire is used in our domestic electric circuits. Why these 2 metals are used? Number 1 answer. Point number 1 is saying both are good conductors of electricity. Both are good conductors of electricity. Number 2, both of them have comparatively less resistance value. The conductors having less resistance value can conduct electricity easily without much loss of energy. So these are the 2 reasons why copper and aluminium are used for electric transmission. Both are good conductor of electricity, both have low resistance value. So that is the end of a long chapter, electricity of class 10 physics. As I told you in one of my video, we can say this is the toughest chapter of your class 10 physics. That's why I have started with this chapter, so that now throughout the year we will get lot of time, lot of opportunity to revise it. Especially you have to concentrate on the numericals. There were a lot of numericals in this chapter, in text and the exercise. Please go through it once again, twice, thrice. So that is the end of this chapter. See you again in the next video with a new chapter. Until then, take care of you and thank you for watching my video. Bye bye.